Thing.
No.
Objective 104. Take 6.
Objective 104, take.
Dude, if
6.
I get one of those, can I do that in this class?
No, I have one somewhere. We used it last year over.
Can I use it?
Yeah.
Sweet.
Okay. Let's go. Attention this way. Alright, this is going to go quick. Because Objective 104 is actually easy. We talked about this perfect square trinomial thing on Thursday. And now what we're going to do is you're going to be given like 2 parts of the trinomial and said, hey, find the third part that would make it a perfect square trinomial. But a couple things we talked about I wanted to make sure that we remember from last week. First was the big Q word, which was quadratic. What do you remember about that word?
Oh, it has the exponent, the square.
X squared.
And nothing about that.
3 or 4, so it's got 4
Nope.
at the fifth.
Yeah. If you're looking at something, like you're looking at up here, and you see we got a trinomial because there's 3 pieces, and you see that one of those pieces is x squared, and there is no x3s, x4s, x5s, and so on, it's quadratic. So we need to get our brain wired to understand when we're looking at quadratic, because most of what you do in Algebra 1 and geometry is all what we call linear, where you'll have y equals mx plus b, and your x will never be squared. But once you start talking about an x squared piece, you're looking at stuff that is called quadratic. And down the road, pretty soon, we're going to have equations that have x squareds in them, and we're going to have to talk about how to solve quadratic equations. Now recall what a perfect square trinomial is, which is this one right here. I'm showing you a perfect square trinomial. A perfect square trinomial happens when, if you take the middle piece, which this one is 10, if you take the middle piece and half it, what do you get? 5. And a lot of times I'll illustrate this by drawing a little arrow, putting a 5 right here. So if you half that 10, you get 5. And then I take it over here and I square it, and I get 25. So half it to 5 and square it to 25. Now I know this isn't on your notes, but I just want to just give you the thought of why this is important. So this is the trinomial. And why is it any different than some other trinomial? Well, if it's a perfect square trinomial, and we went to factor it. And remember, factoring is the process of unfoiling this trinomial. Foil, you put it together. Unfoil is called factoring. We put x's in here. The numbers that go here and here, if it's a perfect square trinomial, they end up being identical. They're both 5s, what I got circled right there. So it ends up being x plus 5 times x plus 5. Or, as you can see in your notes, that's the same as just saying x plus 5 squared. So perfect square trinomials, if you unfoiled them, which if you start recognizing what they are, you won't have to actually do anything. You won't have to unfoil. You'll just go, oh, it's a perfect square trinomial. So it's x plus 5 times x plus 5. Now on this objective, this is not stuff that you have to worry about for this objective, but in general we need to know why we are talking about perfect square trinomials. But for this objective, what you're going to get is the first number, the second number, and then I'm going to ask you to figure out what the third number is. So I have a trinomial right here, but I'm missing the third piece, and I want to figure out what it is. What I need you to do is say, okay, the middle number is 4. So draw a little arrow straight down. And I want you to half that for me. So I'll write the word half here. Half. So half it. Half it, and that's 2.
Then square root it, that's 4.
Not square root it,
Square
it's
it,
just square. Yeah, square it. Square it, and that is 4.
No, it's both.
So x squared plus 4x plus 4 is a perfect square trinomial, and if I factored it, what would you expect to go in here? 2's. Positive 2's. So x plus 2 times x plus 2. That number that I always put underneath and circle, that's the number that goes in. Whether it's positive or negative, that's what goes into the parentheses. So on the back side of I got example 2. I got 14. X squared plus 14x plus. All right, the number that goes here. Take this. 14. Half it. What do you get?
7.
7. So what goes here?
49.
49. So 7 leads you to 49. So,
-4.
now this is the one thing that's different. This is -4 or -8. So what you do is you make -8, half of it is -4.
Square it, yeah.
Yeah. When you square a positive number or when you square a negative number, it doesn't matter. It's always going to come out what? Positive. It doesn't matter if you take 4 squared or if you take -4 squared, it's still positive 16. So on a perfect square trinomial, the third number is always going to be positive. Now the one thing that does matter with positive negative is, so I had to factor this one right here. I'm factoring example 3, so let me shift that right there. If I factored this, what number do you think goes in these parentheses? So here's your trinomial, x squared minus 8x plus 16. So what goes in is not positive, it's what I circled right here, -4. What's half of -8? -4. So the thing that you have there, if you had to factor it, that's what goes in. Keep that in mind. I mean, this isn't on your notes like on paper, but I keep hinting toward this. So you'll see this is the whole point, is that we can see how to factor these things really quick. All right, now we come up on 2 problems. One, the negative, which isn't that big of a problem, but the odd number right here. Now what we're not going to do is, whatever 9 is, if you half 9, you get 4.5. I don't want you to have 4.5 though.
Just half it.
I want you to half it and think of it as -9 halves. You can think of, I don't care if you think negative or positive, it is -9 halves. If you half 9, it becomes 9/2. And then square -9 halves. And when you square, one thing, you could put this in the calculator and square it as -9/2 squared. But we've done this enough that we should know when you square this, it makes 81/4. You square the top and square the bottom, and it's positive. So it becomes positive 81/4. 81/4. So when you have an odd number in the middle, you're going to end up usually with some fraction over 4 right over here. So if it's odd, you half it, just make it 9/2, square it, becomes 81/4. On this next one, you have -7. It's odd, so just make it -7 halves and square it, and it becomes what? 49/4. Now last class did ask, if you say that you had this and you had to factor it, it would kind of actually, it would be weird. What would go in to the parentheses is that right there, -7 halves. And we're not going to see that very much where you factor something and it turns into x minus 7 halves, x minus 7 halves. But yeah, that's what it would be. And the very last question, I want you to think backwards. What if the middle number was missing? Instead of the right number missing, and this is not what you won't see this on Objective 104, but you could see this on an EOI or something. X squared plus something x plus 36. I got to figure out what number goes in the middle.
You square root of 36 and make the 6 and add 6 to it.
Yeah. What is 36 is 6 times 6, so you kind of go backwards. And then instead of double it.
Yeah.
12. So it's 36, that's a perfectly square number, so you square root it to 6, and then you double it to 12. One thing though, yeah, I didn't talk about this last hour. You see how I put this as positive 12? Well, I did have the plus sign right here, which helped. But would negative 12 also be the same thing? Yeah. If I say that I had x squared minus 12x plus 36, would that also be perfect square trinomial? Half it and you get -6, square it and you get positive 36. So there's 2 different answers for that. Of course, we did have the plus sign already in there, which kind of helped. All right, that is it. 104. Very, very simple. Just half it and square it. Half it and square it. Half it and square it. And you got a perfect square trinomial. All right, a lot of time to work today with about 30 minutes.